So using our 3 light rays, the first one says a light ray that comes in parallel will go out passing through the focal point. So I'm going to start out by drawing a light ray that is parallel to the principal axis. And it says that it goes out through the focal point. So from the place where it comes out of the lens, I need to connect that point with the focal point, and that's the direction that that light ray is going to travel. And I'm hoping you can connect that back to what we saw here when we actually shone the light ray in along that pathway. What we saw it do, we saw it go out through the focal point. Okay, the next light ray is the one that goes in through the center. That's the easiest one, right? Because it doesn't change direction. So line up the top of your object with the center of your lens and draw that light ray. It comes in at the center and it just keeps going without bending. And these are hard to draw accurately because the smallest little difference is going to turn into a big difference the longer you draw that line. Try to leave room when you line up your ruler, try to leave room for your pen or your pencil so that it will actually go through the points you want it to go through. Okay, the third light ray, you're going to line up the top of the arrow with the first focal point. And then that light ray is going to go out parallel to the principal axis. Okay, so just to review, one of the big ideas here is that there's a million light rays leaving the top of the object. Lots of those light rays are hitting this lens and passing through. We're trying to predict where that intersection point is, where the image is going to be. For most of those millions of light rays, we can't easily predict which way they're going to go, but there are 3 light rays that have sort of landmarks where we can predict their direction. And so those are the 3 that we're going to draw. 2 would be enough, that the third one serves as a test that you actually have the other 2 in the right places. So drawing 3 gives you more confidence. Okay, let's do them now from the bottom of the object. So going in parallel and then out through the focal point. Then in through the center, continuing without bending. Then in through the focal point. And out parallel. Okay, so here's the bottom, here's the top. A little bit crooked still, but not as bad as my first one. Okay, and so once again, you see it's inverted. And it's smaller now when the object is farther than 2F. Okay. And remember, once you know where that point is, you could draw more light rays if you wanted to, because now you know where they're going to go. So, right, I could say, oh, here's another light ray from the top of the object. And I know that when it goes through the lens, it's going to bend and go out this way. Because every point, every light ray that comes from that point is going to pass through this point. Okay, and that's what makes the image. And this one, I think somebody was pointing out in the comments, was it Elizabeth, that the object distance should have been equal to the image distance, right? Which my diagram is not showing very well. So afterwards, I'm gonna have to go back and figure out what I did not draw accurately on that one. So the last ray diagram here of the basic kind, and then I'm going to teach you a shortcut. This last one, oops, sorry about that, is our fourth situation. So what we're doing is a ray diagram for each one of the things in our data table. There are 4 scenarios here: farther than 2F, at 2F, between F and 2F, and closer than F. So we're doing an example of how do you draw the ray diagram to show how each one of these images is formed. So now we're going to do closer than F, and this is the one where we did not find an image on the index card, and you're going to see why that happened. But we do expect to see an image that's upright and larger. Okay, so this one's a little bit different. So I'll try to go slow enough, but wave at me if you need me to slow down or to do it again, okay? So the first light ray it goes in parallel to the principal axis. So that part, pretty straightforward. There we go. And out through the focal point. Well, so far this seems the same as the other one. So out through the focal point, going to look like this. The next one is, it goes in through the center. So we line up the top of the object with the center. And so far that seems similar, except what do you notice is different? Yeah, Molly?
It's not meeting up with the other one.
Yeah, they're not intersecting, right? So this is different. Okay, and our third one's going to be this is the one that's going to be the most different to draw. Remember here I said a light ray that comes in line with the focal point. This light ray cannot pass through the focal point before it gets to the lens because the focal point's on the other side of it. But it can be in a direction that's in line with the focal point. You see how I've lined it up with the focal point? So it's not going to pass through the focal point because it's not even going that direction. It's going this way, but it's going to be in line with it. So I'll draw a little dotted line to show that I lined it up with the focal point, but it doesn't actually pass through the focal point before it gets to the lens. And then that light ray is going to go out parallel. So now what? We see that we do not have an intersection over here. This is why you could not see the image on the index card, because the light rays are not all converging to a point to make the image of that point that was on the object. But this might remind you of mirrors. Does this remind you of the images formed by mirrors? When we had light rays diverging, if you put your eyeball over here, and these light rays go into your eye, your brain says, oh, got this light ray. Light travels in straight lines. It must have come from this direction. So I like to draw a little dotted line to show that your brain thinks that there was a light ray coming from there that continued this way, but there wasn't actually a light ray right there. And then it gets this light ray, and it says, oh, light travels in straight lines, so that light ray must have come from this direction. And then it gets this light ray and it says, oh, that light ray must have come from this direction. So your brain, when it receives these light rays, assumes that they all came from here because they're diverging in the same way they would have if they had come from there. So this right here is the image of the top of the arrow, since that's where those light rays came from. And this image is a virtual image. And it's virtual because there are not actual light rays intersecting at that point. All of the other ones that we've done are real images. All of these other ones are real images because there's an actual intersection of actual real light rays there. Okay, let's do so did you guys get a chance to extend back your light rays and find that intersection point? Okay, let's do the bottom of the object now. So in parallel, out through the focal point. Then in through the center, continuing without bending. Okay, and then the last one, this one's always the hardest when you're doing these virtual image ones. You want to find the bottom of your object and find the focal point that's on that side of the lens. And you want to put your ruler to line those two up. So it's gonna, the light ray is going to go towards the lens, but it's going to go in a direction that is lined up with that focal point. And with practice, it'll get easier. You'll start to remember where to look. Where to look to line up your ruler. Okay, so we have diverging light rays again. So when your brain gets those diverging light rays, it extends backwards in straight lines to figure out where it thinks they came from. So extend each of those light rays back to find out where they came from. Okay, so that's the bottom of the image. So I can see that it must look like this. And we see that it is upright and it's larger. Okay. Questions about drawing the ray diagram for the virtual image? Okay, so this is why you have to look into the lens in order to see this image, because the light rays have to actually get into your eye and then your brain so that you can do the imagining necessary to see the image. So this is how a magnifying glass works, right? You have to look into the magnifying glass to see that larger image of the object. Okay, I'm going to teach you a shortcut for ray diagrams now. The way we do the shortcut, the reason it's a shortcut is you only have to draw the light rays from the top of the object instead of the top and the bottom. And the reason it's a shortcut, or the way it works, is we take the object and instead of putting it so the object is halfway above the principal axis and halfway below, we put it so that the bottom of the object is on the principal axis. And the reason for that is any light rays that start on the principal axis, their image will also be on the principal axis. You can see here that all the light rays that started, well, for this type of distance, when they all start above, they all end up below. When they all start below, they all end up above. And so you can kind of get the idea that, well, if they started on the middle, maybe they would converge again on the middle. So if they start on the middle, they'll spread out and then they'll spread back together again. So we don't need to draw them for here because we know it's going to be on this line somewhere. So as long as we can find the image point of the top of the object, then we just draw our image to the principal axis because we know that's where the bottom of the object will be. So let's do 2 examples of how this will work out. I think you'll see how it works out. So the first light ray in parallel out through the focal point. The second one goes in through the center. The next one's going to come in through the first focal point and go out parallel. Okay, so this is going to be the top of the object. The bottom of the object is the image of the bottom of the object will be on the principal axis directly in line with that. So here's the image. Okay, any questions on that? Yeah, Peter.
So does this only happen when the actual bottom is on the principal axis?
Yes.
Okay.
Yep. And so from now on, this is how we're going to draw all of our ray diagrams because
Okay.
it's half the work. Although it's not wrong if you do it the other way, but you can do it this way if you want to simplify. Yeah, good question. Any other questions on this one? Okay, let's do our one last one here. It'll give us another chance to practice the virtual image because you can see that the object is closer than the focal point. So the light ray that goes in parallel goes out through the focal point. And the light ray that goes in through the center keeps going without bending. Now, when you get to drawing the last one, you're going to notice that your lens is not long enough on the paper, but that's no problem.
Just noticed that about 3 seconds ago.
Yeah, just make it longer. Going to overlap with the other diagram, sadly. Okay, so in fact, I'm just going to draw it a different color because it dramatically overlaps with my other diagram. So that one's going to go out parallel. Okay, and you can see that we have diverging light rays over here. So the brain has to imagine their origin. So now we extend them back here. hopefully they'll intersect. Okay, and so this is going to be the image of the top of the object. The image of the bottom is going to be on the principal axis because that's where it started. So I'm going to put that directly beneath and then draw my image. Okay, so it's upright and it's larger. All of these will be inverted. The size will depend on where that object is. These are all real because actual light rays are intersecting. And then this one is virtual. Okay, at home, you'll do something with the magnification column in the homework. The paths taken by the light rays explain how these images form. All the light that leaves one point on an object meets up or intersects or converges at one point on the other side of the lens. This point is the image point. When this happens for all the points on the object, you can see the complete image. So you need light from different points on the object to converge at their image point, and then altogether that enables you to see the whole image of the whole object.